Hi, I'm Thomas from Zano Controls technical team, and today I'm going to be talking about how we test lamps and drivers on not just a range of dimming products, but also for things such as power factor and inrush current. So just behind me we have our main fixture. We have several rows of independently switched lamp holders along with some individuals, so we can mix and match loads as we need. Below we have some connectors so we can plug in some drivers and downlights. So let's talk about power factor and inrush current, as typically the two go hand in hand. Power factor is the phase difference between the current and the voltage of the driver. Typically, the capacitors inside the driver that consume this large amount of current on initial turn on are what cause the difference between the current and the voltage's phase. We can measure power factor using something called a power analyzer, which, when connected up to the load, will give us a readout of not just the power factor, but the wattage, and therefore, using the two of those, the VA. So let's measure the power factor of two different 5-watt LED lamps. Firstly, a row of 10 of type A lamp gives us a power factor of about 0.59. What this means is that even though those lamps are 5 watts and there's 10 of them, you would expect 50 watts. But after accounting for power factor, the actual VA is around 95. So let's measure the power factor of two different types of 5-watt LED lamp. Lamp 1 gives us a power factor reading of 0.58. What this means is that the actual VA of this load is just over 95 VA, far above the 50-watt rating. Let's now test lamp type 2. Lamp type 2 is much better, giving us a power factor of 0.92. This means they'll be much closer to the 50-watt rating, and as we can see, there's a 58 VA. Let's do some close-ups in the same shot, 'cause then we can put it on the video. Go into focus. Why doesn't it like focusing? No, come on. That's the wrong one. That's better. There's VA. Just like a screenshot. There's the power factor. I'm going to put on lamp 1, the bad one. There's power factor. And there's the VA. Power factor is the difference in phase between the current and the voltage. We can measure the power factor using something like a power analyzer, and we can also see the different waveforms using an oscilloscope. For example, the way we measure inrush at Zano is we set our oscilloscope to trigger on the first current spike. We can then turn our device on and off and measure the inrush current. You must take care in ensuring the capacitor is fully discharged in between readings. Otherwise your values will be lower, as you already have partially charged capacitors inside the driver. So let's have a look at the current and voltage waveforms for these two LED lamps. First we've got lamp 1. Here we can see, with the current in yellow and the voltage in purple, a very different pattern of waveform between the two. These lamps, the lamps with the worst power factor, have a huge spike in the middle. We can see the scope is reading a current spike of up to 1.8 amps. Now let's put on lamp 2. As you can see, lamp 2 not only has a better waveform, but lacks the spike as well, with the maximum current being read at just over 500 milliamps. The way we measure inrush at Zano is we set our oscilloscope to trigger on the first current spike. We can then turn our device on and off and measure the inrush current. You must take care in ensuring the capacitor is fully discharged in between readings, otherwise your values will be lower as you already have partially charged capacitors inside the driver. So to demonstrate measuring inrush, we can first turn our driver on, make sure it's the only thing on that's connected. We will allow the driver to discharge and set our oscilloscope to single trigger. Here we can see on a single 150 watt tape driver an inrush current of well over 10 amps.